Good morning, students. Today we will discuss how to write material balances over a distillation column. Okay, what is a distillation process? If you see, distillation is an unit operation. Distillation is an unit operation, and it is a separation process. It is a separation process based on, means we are separating A and B, to say two components, based on what? Based on relative volatilities. Relative volatilities of the components that means based on boiling points of the components. Boiling points of the components. Okay. So the process is to separate two or more components based on their boiling points. Distillation process is the process to separate two or more components based on the boiling points. So if you consider only two components separation, we call it as binary distillation. We call it as this. What we are going to discuss is only binary distillation. Okay, we are going to discuss only binary distillation. Two components, say those two components are A and B. Okay, those two components are A and B. Now we shall discuss the distillation operation with help of a diagram. Here, let this be distillation column. Let this be distillation column. We are sending the feed here. Let the feed is say F kg or grams, whatever it is. And this contains two components, A and B. The two components are A and B. Now, the more volatile component, we select usually like this, component A, more volatile, that means less boiling point. That means the component which is having less boiling point will evaporate first. So this is component A comes here, more A and less B. So this component, after the vapor is formed, we send it to the condenser. Now from condenser you will get the product in the liquid form, and a part of the product is sent back to the distillation column as a reflux, and the part is withdrawn as product D. This is what is happening to the top product here. Now we get the bottom product here. Let this be V. V is the amount of vapor that is formed. So here V contains more A and less B. B is also volatile only, but it is less volatile. So less amount of B goes to the top product. So here V, and this V is condensed here, and a part R is refluxed and D is coming out, and here let it be W. Okay, this is bottom product. And this is also called bottom product or residue. Okay, and this is D is top product. This is a top product. And here component A is more volatile, less boiling point. So component B is component B less volatile and more boiling point. Less volatile and more boiling point. So this is our assumption. And the particular feature of this here of the distillation column is here composition of V, R and D are same. This is one particular feature here, because vapor is forming here. This vapor form contains what? More A. Vapor forms contains more A and less B. Okay? Vapor contains more A and less B. So whatever the vapor that is formed, the same amount will be condensed here and the same composition solution is formed here. So but some part is reflected back, because in the distillation column we cannot, in mass transfer you will study, we cannot run the distillation column without this reflex. So a part is required to be reflexed to the column. So whatever the R we are sending back, the rest, whatever the rest of the amount we are withdrawing as the product, the composition is same. So V, R, D. Suppose V contains 97% A, R also contains 97% A, D also contains 97% A. So the composition is uniform here. Then that means D also same thing here. D also more A and less B. So this is called top product here. And W contains what here? Less A and more B. That is W. So thus we are separating A and B. A is going into the top product. B is coming down into the bottom product, which is less volatile. Here it is coming to the bottom product. Okay. Then some other notation we will write first before trying to write the material balance over distillation column. So let F is weight of feed is equal to, let it be F kg or kg per hour also sometimes, no problem. If you take basis as 1 hour, it will be only kg we write, otherwise kg per hour we write. Same thing applies to all terms. So weight of feed, then weight of distillate D kg. Okay, so these total weights we are writing here. Then weight of residue is W kg. Okay, so F kg is entering, D kg is obtained. We don't consider R because R is being reflexed back. W kg is obtained from bottom. Then for component A balance, then balances also we write. Before writing that component balance, we shall assume another one. Always select component A as more volatile. Component A always more volatile. That means this top stream contains mostly A. So weight fraction of A in feed. Okay, this is the notation we are going to use. XF is what? Weight fraction of A in feed. Similarly, weight fraction of A in distillate. Weight fraction of A in distillate here. Distillate is XD. Okay. Then weight fraction of A in residue is equal to XW. Okay. So this is the notation we are following. And in the same way here, weight fraction of B in feed. Weight fraction of B in feed. Here B, because A is XD, here A is XD we assumed now. So what is B now? 1 minus XD. Okay. So weight fraction is 1 minus, it is F. A is F. So here it is 1 minus XF. Okay. So similarly here, this we assumed it as XD. A is XD. Therefore here 1 minus XD is B. Okay. So weight fraction of B in distillate is equal to 1 minus XD, and weight fraction of B in residue is equal to 1 minus XW. So here XW is A. Therefore 1 minus XW is B. Okay. So 1 minus XW is B. So this is the notation we are going to follow to write the material balances. So what are the important points we should remember when we write? Composition is same for V, R and D. And another thing is here we use XD, XF, we use XF, XD and XW or for component A. This is the easy way to remember. Okay, XF, XD, XW we use only for component A. Then naturally the other things, that is 1 minus XF, 1 minus XD and 1 minus XW are for component B. Okay, this we need to use when we write the material balance. So when we write the material balance, here we divide into two parts. In the first part here, we consider this part. Okay, we consider this part here. This part we consider. We try to write the material balance for this. That means whatever the lines that are crossing this broken lines, they are inputs and outputs. So for the entire distillation column, we are going to write material balance. Material balance for the distillation column. For the distillation column. So what we write here? F is the input here, D is the output, W is also coming out. So arrow mark inward 1, outward 2. So F is equal to D plus W. This is overall balance. Overall balance. Okay, let it be equation 1. This is the overall balance. So overall balance, F is what? Feed is equal to distillate plus residue. This is the overall balance. Okay. Total weights we take. Next, component balance. Component balance. How many components are there here? 2 components. So 2 components are there. 2 components, A and B. 2 components are there. Okay. Then we write A balance first. A balance. Okay. So what is A balance? Whatever the A present in the feed must be equal to A present in the distillate plus A present in the bottoms here. Okay. So A balance is A in feed is equal to A in distillate plus A in residue. This is A balance. Okay. So A in feed is what? Weight fraction of A in feed is XF. Total weight is F. So F into XF. So this is A in feed. Next, that is equal to A in distillate. Total distillate is D. Weight fraction of A in distillate is XD. So D XD. So this is A in distillate plus A in residue. Total residue is W. Then weight fraction of A here is XW. So this is XW. This one. This is, let it be equation 2. Okay. Thus we wrote the material balance for component A. This is the material balance for component A. Then we shall write the material balance for component B. Material balance for component B is what? B in feed must be equal to B in D plus B in residue. B in feed is equal to B in distillate plus B in residue. Okay. So B in feed. Feed is total feed is F. B in feed is 1 minus XF. So 1 minus XF is equal to B in distillate. Total distillate is D and 1 minus XD is B. So 1 minus XD and also W into 1 minus XW. 1 minus XW is B. Total is W. This is material balance for, let it be equation 3. Okay. Thus we wrote 3 equations. Overall material balance and component balances, A balance and also B balance. Okay. This is for the entire distillation column. Now we shall write another part, material balance for another part, that is only for the condenser here. For the condenser we draw the material balance. Okay. Here. So this is the input here and this is the output here for the condenser. So condenser balance. Condenser balance. So input to the condenser. Input to the condenser must be equal to output from condenser. This is a condenser balance. What is the input to the condenser? Here V. Overall. This is overall. Overall balance. Okay. Overall balance only we consider here. There is no question of component balance because everything is same here. So V is equal to R. R is coming out and D is also coming out. And there is no necessity actually for writing separately. This is enough. V equal to R plus D. This is the balance for the condenser. Let it be equation 4. Remember that composition V of V is same as R and also same as D. So V equal to R plus D. This is another equation. And you divide throughout with D. V by D is equal to R by D plus 1. So R by D is equal to V by D minus 1. This is an important equation useful to find out the reflex ratio. This is called reflex ratio. This is called reflex ratio. So what is reflex ratio? How much R we are sending? How many kg of R we are sending per kg of product that is obtained? That is called reflex ratio. Okay. So what is the application of this material balance equations? Because the chemical engineer, when he is operating the distillation column, he needs to know if he wants to send some 1000 kg of feed per hour like that, then what amount of D will be obtained and what amount of W will be obtained. So those calculations, before only the engineer needs to do all these calculations. And also it is necessary to calculate what amount of R is to be reflexed back. Only that much amount they will send back to the column. For that purpose, it is necessary to calculate reflex ratio R by D also. So next class we will solve problems for this distillation column, and in those problems usually F will be given. If F is not given, we can assume, say 100 kg or 1000 kg, whatever it is. So F will be given, and the composition of the streams also will be given. That is composition of like XF, XD, XF, and XF, XD, and XW will be given. And it will be asked to find out what total amounts of D and W will be obtained, and what will be the reflex ratio to be maintained. Thank you.